man talking himself, because my name is Democritus, and I was born in 550 BC. Oh, look, it's paper. Slice? Whoa, this is still paper. Somehow I thought it was going to change into something else magically. Slice? Oh my god, it's still paper. Slice? Slice? They're all still paper. I propose a theory that everything is made up of little teeny particles. Yes. Too bad my theory was not testable and no one lied to me. Yeah.
I'm Antoine Lavoisier. Oh. I lived in the 1700s, and I invented the law of conservation of mass. Alright, this piece of paper is 6.9 grams. When it reacts chemically, it'll still weigh 6.9 grams. Because that's the law of conservation of mass.
I am Joseph Louis Proust, born in 1754, and I will die in 1826. My law of definite proportion says that given compounds always contain the same elements in the same proportions by mass. For example, take this shoe. It's got some blackium, some goldium, and some whitium. This compound shoe. Now let me take this other compound shoe. Whitium, goldium, and blackium in the same proportions. Thus, shoeisium is always 1 part goldium, 1 part blackium, and 1 part whitium. This explains my law. The law of multiple proportion says that when two elements from a series of compounds, parentheses, H2O and H2O2, parentheses, the ratio of elements are always whole numbers. For postulates, each element is composed of extremely small particles called atoms. All atoms of a given element are identical, parentheses, but they differ from those of any other element. Atoms are neither created nor destroyed in any chemical reaction. A given compound always has the same relative numbers and kinds of atoms. Dalton thought that atoms were hard and round, much like extremely tiny marbles or ball bearings, but he was wrong. I just had to add that, In mid-1800s, scientists began working with how electric currents travel through partially evacuated glass tubes, cathode ray tubes. Yeah, what? Oh crap, I'm not done. Cathode ray tube.
You can't say crap.
It's fine. Crookes tube, evacuated glass tube, in which a stream of electrons emitted by a cathode strikes a fluorescent material, causing it to glow. Cathode, negatively charged electrode. Anode, positively charged electrode. By the end of the 19th century, scientists knew several facts about the cathode rays. Cathode ray could spin a small paddle wheel, which suggested that it was actually a stream of particles. A magnet deflects the cathode ray in the direction expected for negatively charged particles, suggested that a cathode ray was not only made of particles, but the particles carried a negative charge. The problem became determining the mass of this part.
We decided that each clip was going to be 45 seconds long, remember? J.J. Thomson conducted experiments with the cathode tube ray and determined that particles have negative and positive charges. He discovered this by streaming particles through a cathode tube, and then by adjusting the magnetism, he could affect the direction that the stream changed. And that's basically what this is. See, as I put my fingers, I have magnetic charge, and I can change the direction of the particle stream. And he said that atoms were positive.
Make one strand by putting your entire palm on it.
Oh, then they can see it. Hold on.
Yeah. Oh, move your hand to the side. Yeah. Yeah, there you go.
Alright, that should be enough. Alright. Ernest Rutherford did experiments with thin sheets of gold, and he said that the particles that hit it, only 1 out of 8,000 reflect off of the object, and almost all of the objects are absorbed. Yeah, and he also could change the direction of the beam with magnetic plates. He disproved the plum pudding model. Rutherford also said that most of the stuff in the atom is in the very middle, and a lot of the atom is actually empty space.
Yeah.
Where's the atom? You can stop. Henry Moseley measured the positive charge of the nucleus of many elements. He provided quantitative evidence for the atomic number and allowed for the reorganization of the periodic table. Niels Bohr came up with the idea that electrons orbit the nucleus in a way similar to how planets orbit, but with magnetic forces being the main forces of attraction instead of gravity. And it's called the Bohr model.
James Chadwick, born in 1891, discovered the neutron, named so because of its lack of electrical charge. The neutron... Yeah.